All right, let's talk about architecting for real, massive scale. If you're a senior architect, you've probably felt this pain. Your app gets popular, and suddenly the database becomes this huge bottleneck. So today, we're going to demystify one of the best tools out there for crushing that problem, Amazon DynamoDB. Let's get into it.
We've all been there, right? You build this elegant, perfectly normalized relational database. It's beautiful. It works great. At first. Then, the traffic spikes. Queries start timing out. And before you know it, you're in some late-night meeting scrambling to figure out how to scale a system that just wasn't designed for this kind of pressure. It's a nightmare.
And this really is the fundamental issue, isn't it? As architects, our job is to plan for success. We need to build systems that can handle tomorrow's load, not just today's. That constant worry about hitting a performance wall or dealing with crazy, unpredictable latency, it's a huge source of stress and technical debt.
And that is precisely the problem DynamoDB was created to solve. Now, it is not a relational database, and it doesn't even try to be. It's a fully managed key value and document database built from the ground up for one thing and one thing only, delivering incredibly consistent, high performance at pretty much any scale you can imagine. So, why do teams at places like Amazon, Disney, and Dropbox build on this thing? Well, first off, it is built for massive, planet-scale operations. Second, the performance is just incredibly predictable. We're talking single-digit millisecond latency all day, every day. And third, and this is a big one for architects, it's serverless. That means zero servers for you to manage, patch, or worry about. You get to focus on your design, not the infrastructure. Okay, to really use this power, you have to make a huge mental shift. Seriously, if you take one thing away from all of this, let it be this. With our old relational databases, we think about the data first. With DynamoDB, you start with the questions. You literally design your database around your queries.
This quote just says it all. You don't sit down and model your data entities in some perfect, normalized world. No, you figure out every single way your application needs to access data, like get a user by their user ID, or get the last 10 orders for this specific customer, and then you build a schema that makes those exact lookups ridiculously fast.
And this comparison just lays it all out. With relational design, you start with your data, you normalize it to get rid of any duplication, and then way later, you figure out your queries. DynamoDB completely flips that on its head. You start with the access patterns. You actually denormalize and duplicate data on purpose to speed things up, and you design the table to perfectly fit those queries.
So, how do we actually build a table like this? How does it enable this whole query-first thing? Well, it all comes down to two main pieces, the partition key and the sort key. Getting these two concepts is absolutely fundamental.
Think of the partition key as the address for your data. It's like the label on the outside of a huge filing cabinet drawer. When a request comes in, DynamoDB looks at the partition key value and instantly knows which physical server, which drawer, has your data. That's the secret sauce to its incredible speed.
Now, if the partition key is the drawer, the sort key is how all the files inside that one drawer are organized. They could be sorted by date, by price, by status, whatever you want. This lets you run super efficient queries inside a single partition, like, hey, get me all orders from last month, or find all products that start with the letter A.
Okay, enough theory. Let's make this concrete. Let's imagine we're designing a table for customer orders on a big e-commerce website. The number one goal here is to make sure our data and all the requests hitting it are spread out evenly across the whole system. Because the one thing we absolutely have to avoid is something called a hot partition. You can just think of it as a massive traffic jam. It's what happens when way too many of your requests all slam the same partition key at the same time. It just overwhelms that one piece of the system and your performance goes right out the window.
So check this out. A really poor design choice would be using something like order status for your partition key. Why is that so bad? Well, think about it. On any given day, you might have tens of thousands of orders with the status shipped. All of those requests would hit one single partition. Total disaster. A much, much better design is using the customer ID. Because customer orders are basically random, your access gets spread out nice and evenly. The key takeaway? You need a partition key with high cardinality. That's just a fancy way of saying it has lots and lots of unique values. So let's switch gears a bit and talk about how these design choices affect your wallet. The way you pay for DynamoDB is directly connected to how you design your table and how you predict your traffic. You've basically got two main options here. On-demand is absolutely perfect for new apps or anything with spiky, unpredictable traffic. You just pay for exactly what you use. Super simple. Then you have provisioned capacity. This is usually better for stable, predictable workloads. You tell DynamoDB exactly how many reads and writes you need per second, and you can even use auto-scaling to tweak it. It's often cheaper if you actually know your traffic patterns.
Okay, that was a lot to cover. So, to wrap things up, let's just boil this all down into a really clear, actionable checklist you can take with you to your next project.
All right, first up, the do's. And I'm going to say it again. Always, always know your access patterns before you do anything else. Always choose partition keys with tons of unique values. Think user IDs or UUIDs to keep things balanced, and really take advantage of that sort key for powerful, efficient range queries. And, just as important, here are the don'ts. Do not try to force a relational model onto DynamoDB. You'll just be fighting the system the whole time. Also, it is not the right tool for complex, ad hoc analytics queries. And never, ever choose a partition key with just a few values, like that order status example. And finally, don't forget that every single design choice you make has a direct impact on your bill.
At the end of the day, it really all comes down to this one simple question. Look, a traditional database might get you to your first 1,000 or 10,000 users, but really planning your architecture with a tool like DynamoDB means you're already building for that next million. It's a totally different way of thinking, for sure, but it is the key to building systems that can truly scale.